Hi students, we're going to use inverses. The whole point of the inverse is to solve when you have a bunch of variables. Now I'm going to teach you by just doing two variables, but please know this works when you have an unlimited number of variables. But if I try to show you using that, I think you would probably hurt me. So here we go. Let's say that you have this equation and or this system, and you had to change this to a matrix. The way to do it is I don't use the x and y yet. Here's my x's. I have -2 and 2 for the x's. For the y's, this was already aligned. So if it were not aligned, I would align it with like terms in corresponding places in these equations. So here's -4y, +3, and I am going to say times x, y. Now I know that you're saying, whoa, this is your x column, this is your y. Isn't this wrong? No, just think about it. If I were to multiply -2 to -4, 3 by x, y, right? I'd get -2x minus 4y, 2x, 3y, if I use that little matrix multiplication thing, right? So again, your x's are aligned vertically, your y's are aligned vertically, and then your x, y, your x's on top and your y's, if this had gone across, they're horizontal. I don't know if you caught that, but remember, this is my x, this is my y. If there was a z, if there were 10 variables, they would be stacked by variables. Now, this is equaling 6, 5. Now, in interest of full disclosure, I'm going to tell you this is not my favorite way to solve these. I will show you my favorite way to solve these because it's fast and it's more accurate. But for right now, I got to show you the ropes. So here we go. This is my matrix. I converted this to this. So the experts say if I can find the inverse of my coefficient matrix, so this is my coefficient matrix, and this is my variable matrix. And I assume this is called my constant matrix. I should look that up, but not right now. Okay, so what I have to do is I simply got to find the inverse of my coefficient matrix. Step 1, find the determinant. Step 2, do 1 over the determinant times that where I did the A, B, C, D. Remember that? And then I'll show you step 3. So let's do step 1. If I have this -2, -3, all right, I'm going to take -2 times 3 is -6 minus -8. So -6 minus -8, isn't that 2? And I believe it is. So that was step 1. Step 2 is to do 1 over 2 times, I'm going to take this matrix, and these two are going to switch places. This will be my 3, my -2, and then change the negative positive signs on the DB combination. And now multiply. 1/2 times 3 is 3/2. 1/2 times 4 is 2. 1/2 times -2, that makes -1. 1/2 times -2 is -1 again. Now, here is my inverse. And the reason why they wanted me to do my inverse, because if I multiply this inverse by the coefficients, by the constants, sorry, then I should get my answers. And here we go. So 3 times 6 is 18, divided by 2 is 9, plus 10 is 19. -1 times 6 is -6, and -5 is -11. So what they're saying is that x is 19 and y is -11. Let's see. Negative 38 plus 44 would be 6. And then 38 minus 33 would be 5. Okay, I think those are right. That's how you solve. Now, I know you're saying, but I could just solve this so easily, Miss Wilson. I agree. But if you had 3 or 4 or 5, no, you couldn't. If you had 3, it's hard. 4, oh my goodness. So that is a point. But I did not finish these directions. I'm going to write them down here for you. Okay, so step 1, find the determinant. Step 2, use 1 over the determinant times the little scramble here to find the inverse matrix. Multiply the inverse matrix times the constant matrix, like we did here, to find the unknown values. You need to add this to your notes. And now I have something else for you to add to your notes, and this is how to do a 3 by 3. Now, if this were not valuable, I would not be showing you this. But this has, this will do little things for you that, in geometry, that you'll be so glad you know, so especially for the SAT. So I'm going to make a 3 by 3 matrix. I want you to see something. Let's say I told you that I wanted you to do a 3 by 3 matrix by hand. What I want you to do, instead of doing that really complicated thing, is I just want you to not consider this a line and redo the first 2 columns. Like this 147, I'm going to repeat it right here, and the 258. And the reason you do this is because it makes it really easy to calculate. You'll see. Now I'm going to start with the top left. Notice we always start with the top left. Have you noticed that? And I'm going to take this and I'm going to multiply them. 1 times 5 times 9 is 45. Plus, I'm doing the dot product. 2 times 6 times 7, well, that's 42 times 2 is 84, I think. And then 3 times 4 times 8, let's see, 12 times 8, gosh, I hope that's 96, I'm not sure. Let's hope. Okay, I added those, and I always do this to remind myself. I'm going to subtract. I think of this like the fish. It's just like you know how we do this with the 2 by 2? I'm doing the same thing. I'm doing that, and that, and that, if you will. And now I'm going to subtract going the other way, just like you do with the 4x4s. So here we go. So where do I start? On the left, top left. That's why I moved 2 rows over here so I wouldn't have to do funky stuff. So I didn't think of this. I don't want to make it sound like I did. So now I'm going to take, starting with the top left, 2 times 4 is 8 times 9 is 72. And then 1 times 6 times 8, I hope it's 48, plus 48. I'm adding, the only thing I subtracted was the turnaround. And then 35 times 3 is that 105? I do not know. Hope so. I should have looked it up before I started doing this stuff. All right, and now I just calculate that. And doggone it, I got 0, which means it's not non-singular. Dadgummit. Okay, let me explain. When you get 0, that is, you always want a non-singular matrix. Non-singular means it's a regular matrix. When you get 0, it means you have the same equation. Let me show you. Let's say you have the expression 2x plus 4y. Isn't that the same line, you know, if they're equal to whatever constant, as 4x plus 8y? Aren't those just, they're similar, right? 2, 4, 4, 8. I should have given a constant, but still, I just want to stick with the square matrix. Look, 2 times 8 is 16, minus 16 is 0. When you get 0, you just have equivalent equations. They're the same thing. And I wish I had, but I just used 1, 2, 3, 4, 5, 6, 7, 8, 9. You think I would have known better, but no. I'm going to do it one more time. No, I'm not. We're almost at 10 minutes. You're probably tired of it anyway. I'm going to teach you in class. It doesn't really matter, does it? But anyway, I like doing the 3 by 3 matrix. It's worth learning, I promise. because I'm going to show you. I mean, I like it better than that one, just because that's clear as a bell to me. Anyway, you guys take care. Bye.